Hello, virtual people. We are going to be working our way through this Happy Meal packet, and the goal of this packet is to try to answer the question, if there are 6 Happy Meal toys and I want to collect all 6 toys, how many Happy Meals am I going to have to buy for that to happen? And this is something that was really big back in the 1990s when McDonald's had a really cool toy. It was very cool to like go out and collect all of the toys. I know that's not really the case anymore, but what we're going to first do is simulate. We're going to run a simulation of this scenario. So in this, what we have these 6 toys, the 6 Pokemon Happy Meal toys, and we want to try to figure out if there's an equal chance of getting any toy, how many Happy Meals would I have to buy in order to collect all 6? And for this first part, what you're going to need a die, a 6-sided die, or if you don't have any dice at home, then you can go ahead and Google like a dice simulator online. They are all over the place. Any of them will do. So what you're going to do, and I'll kind of do the first one, and you can feel free to listen to the first part and then skip ahead as necessary, but each number on the die is going to represent one of the 6 toys. So I'm going to roll. I roll my dice. I got a 2. And I'm going to put a little hash mark here. So I'm going to keep rolling. That time I got a 4. I got another 2. So that would be like my 3rd time going into McDonald's. I get the same toy that I got the first time. Oh, another 2. So I'm going to keep rolling until I see at least one of each toy, because my goal is to have at least one of each. And so far I'm not doing so well. I still need a 5 and a 6. Nope. There we go. Now all I need is a 6. Ooh, first try. Okay. So now I have at least one of each, and I'm going to count up how many times did I actually have to roll. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I had to roll 10 times before I saw each number at least once. So what I want you to do is do the same thing that I just did. If you have dice at home and you just want to roll one of them, that's fine. If you want to Google a dice simulator, that is totally fine as well. Okay, so you're going to do this 4 times. I just did it once. And you can go ahead and pause this video while you gather those numbers and continue once you have all of your data. We need data from the entire class to answer question 2, so we are going to skip ahead to problem 3. On this table, so what we're going to fill out, we're going to actually fill out some probabilities. On the top, I know it says meals needed to get a new unique toy, and then on the side it says additional meals needed. So first, we are going to do this first part of the table, and we're going to consider it maybe not meals needed, but I'm going to think of this as probability. The probability of getting a new unique toy. So for this first scenario A, so looking at scenario A, here we have 5 of the toys, and we're trying to find what's the probability of getting that 6th toy. We want to fill out this box, what goes there. So we ask ourselves, if I have 5 toys, there's 1 toy that I want, there's 1 missing toy from my collection, so there's 1 toy that I'm looking for out of the 6 total possible toys. So the probability that I'm going to get that last toy that I want is 1 in 6. If we look at scenario B, now we have 4 of the toys. So if I have 4 of the toys, I walk into a McDonald's, what is the probability that my 5th toy is a unique toy, that my 5th toy is one of the 2 toys that I don't have? So if there are 2 toys that I'm looking for, and there are 6 toys total, my probability is going to be 2 over 6. Now I'm going to reduce that fraction to 1/3. But the 6th toy, so this is going to follow a pretty predictable pattern, so that 6th toy the probability of getting that 6 toy is still 1 out of 6 because there's still the one missing toy, the one toy that I don't have, divided by the 6 total possible toys. Now if we go down to scenario C, now we go into a McDonald's, we have 2 of the toys, so the probability that the toy that I get is one that I don't already have. There are 4 toys that I don't have, still out of 6. And if I reduce that, that's going to give me a probability of 2 over 3. We're going to keep filling out this table, keep following the pattern. So if I have 3 of the toys, so I'm looking for that 4th toy now, I'm moving to the right. There are 3 toys that I have, 3 toys that I don't have. So 3 toys that I don't have out of the 6 possibilities. That's a 1/2 probability. The 5th and 6th toy, they're actually going to mirror the row above this one. So if I have 4 of the toys, there's still 2 that I want, and it's still out of the 6. This last one is always going to be 1 over 6 because that last toy, there's still only 1, but 1 out of 6 because there's still 6 possibilities. Okay, so now we filled out a probability chart. What we are going to do next is we're going to try to fill out this column. Now to fill out this column, we need to know a property that you don't know yet. So here's that property. If P is the probability of success, then, so P is probability of a success, then 1 over P is the expected number of trials for success. And I'll explain that. And to explain that, I'm going to go back up to this first scenario A. So with this first scenario A, the probability of success was that 1 over 6. So this 1 over 6 is that P value, the probability of success. Now, if the probability of success is 1 out of 6, the question is, how many trials do I need to expect one of them to be successful? So the probability is 1 over 6. How many trials do I need to expect one of them to be successful? And this property is saying down here that it's 1 over P. So if it's 1 over 6 is P, then 1 over P is its reciprocal. It's 6. And I hope that intuitively this might make a little sense. I know that it can be confusing. But if the probability that I get that last toy that I want is 1 in 6, then I should expect to have to go into the store to buy a Happy Meal about 6 times. And that should, I'm not going to use the word guarantee, but I should expect success that way. Now what we do for scenario B, once we have more than one thing, so for scenario B, I have 1/3 and I have a 1/6. What we're going to do is we're going to add these together, or we're going to add their reciprocals together. So instead of 1/3, I'm going to use 3. Instead of 1/6, I'm going to use 6. So that would be 9. I would expect to have to go into McDonald's an additional 9 times to get those last 2 toys. And if we look at scenario C, and this one's a little different because that 2/3 doesn't give us a nice whole number like the other problems did. But we're going to add these together. So I'm going to, sorry about that. Going to have 3 over 2 plus 2 over 1. I'm just going to write 2 plus 3 for the 3 over 1 plus 6. So what does that give us? That gives us 5, 11, 12.5, which we can consider that to be 13 because it really doesn't make any sense to go into McDonald's and buy 12.5 Happy Meals. So that's about 13. Okay, so So for problem 4, what I'll do is I'll try to get you started, and then I'm gonna ask you to pause the video so you can try it on your own. What you're trying to do with problem 4, so starting from scratch, you go into McDonald's, you have no toys. So if we try to fill out a table sort of like we have on the top of your page, if we're trying to fill out a table here, one, two, three, four, five, six. So if you go into a McDonald's, you have no toys, what's the probability that you get a unique toy? And you're gonna put that number here. And then once you have one toy, what's the probability that your next toy is gonna be a unique toy? And you fill in that number here. So you're essentially trying to continue the table from the top of the page as if you had a row with absolutely nothing in it. So try to do it on your own. Hit pause on this video. Try to answer that on your own. Once you have a solution, press play on the video. I am gonna walk through it. So try it on your own first though. Hopefully you actually did pause this video and try the problem on your own. So if I walk into a McDonald's, I have no toys, I buy a Happy Meal, the probability that I get a unique toy is 1. It's 100%. I don't have any toys, so I have to get a unique toy. I'm gonna write it as a fraction to try to match all my others. I'm gonna call it 6 out of 6. There's 6 toys that I don't have out of the 6 that are available. For the next toy, so I have 1 toy. There's 5 that I don't have. If we keep going, I have 2 toys. There are 4 that I don't have. And then again, I'll reduce that fraction. I have 3 toys. There are 3 that I don't have. I have 4 toys. There are 2 that I don't have. And then lastly, I have 5 toys. There's 1 that I don't have. We're going to use the same property from the rest of the table to try to find the expected number of Happy Meals. So for this, we are doing that whole 1 over p thing, where p is the probability of success. So if I flip these fractions, if I flip 6 over 6, I still have 6 over 6. There we go. Plus 6 over 5, plus 3 over 2. When I flip 1/2, I just get 2, and then 3, and then 6. And if I add all of these together, I'm gonna get 14.7. Now we know that we cannot buy 14.7 Happy Meals, so we're gonna say about 15. So if we have nothing, we have no toys, if I want to go in and try to get all 6 toys, I can expect to buy about 15 Happy Meals. Since we are told on the front of the worksheet that a Happy Meal costs $3 each, although I think that the number is actually $4 in real life, but if it's 3, then we are going to spend, so $3 each, 15 meals, we're looking at spending $45. So if we're spending a total of $45, if the question is how much is each toy worth, if I'm spending $45 on the 6 toys, I'm spending about $7.50 per toy, which is probably more than it's worth. For the next question, for question 5, this one is you on your own. There is no wrong way to answer this as long as you back up your statement. So the question is, should McDonald's give the opportunity for me, the consumer, if I want to walk in and say I want a Woobat toy, and for them to charge me a specific amount just for that one toy? So do you think that would be a good strategy for McDonald's? And there's no wrong answer. It's an opinion question, but make sure you back up your claim.